In this video, we're going to look at parabolas and both the components that create a parabola and the process for writing the equation when we're given those components. So first we have the definition of a parabola. This shape of a parabola is created by identifying all of the points along it, because this is an infinite number of points along the shape, that are an equal distance from one point that we call the focus and a second line called the directrix. For example, the point here on the parabola is the same distance from the focus down to the directrix, and another point out here is pretty easy to read. The distance is 2 across, and it's 2 straight down. Some of the other points would be a little bit harder to measure, but the idea is the same for all of them. The distance from the points on the parabola are equally spaced from the focus to this directrix line at the bottom. Next we have the vertex, which is one of the points on the parabola itself. Specifically, it's the one on the axis of symmetry, so it's the one where the two separate halves of the parabola meet together. Next we have the focus, which is a point that's not on the parabola itself. This is a point that the parabola is going to move towards. And then the directrix, this is the line that you're going to see the parabola kind of move away from. So wherever the directrix is, the parabola always goes in the opposite direction away from that. And those two terms are what we use to create the shape itself, of course, as well. And then the last term we want to recognize is the focal width. If I asked you how wide is the parabola across, well, the distance varies based on where you're looking at it. So the way we agree to describe the width of a parabola is by describing its width specifically through that focus point itself. So in this case, the focal width is 4, as an example. Now let's start to apply numbers to some of these concepts. First, we want to talk about the coordinate for the vertex. We're going to be using the variables h and k to describe this x and y coordinate. It's also helpful to know that this point will always be exactly halfway between the focus and the directrix. So if you know the location of the other two objects, you can always find the vertex by cutting the distance between them in half, finding that midpoint between them. The next variable we want to define is p, and this one will be used several times. P is going to be the distance from the vertex to the focus. So if I drew a line from the vertex to the focus, that length will be p. Now, since the distance from the vertex to the focus is the same as the distance from the vertex to the directrix, we could also use that length to say the distance from the vertex down, in this case, will also be p. So the distance from the vertex to the directrix is that same number. And then the last time we're going to use that variable, if we take the absolute value and multiply the number by 4, then that is going to end up being this focal width that we described earlier. So finding p is very important for parabolas because it gives us several of the distances and widths of the shape across. My advice to you on this unit is going to be that you always take the variables that they've given you. So if they give you like the coordinate of the focus or they give you the coordinate of the vertex, I would always just draw a rough sketch of those points, and then you can measure the distance between the ones you have and find the other distances so that you can figure out the formulas for those parts as well. This parabola here, for example, has the vertex 2, -1. So that's the h and the k value. We can measure this distance between the vertex and the focus just by looking at it, or by going down. It would be the same length either way. That's a length of 1. And then using the focal width across, that's 4, so you could also use that to find that p is 1, or you could do the distance from the vertex down to the directrix. That would also be 1. So all of those give you the value of p. And then what we're going to learn is that we can take these three numbers we just found, and then we can write the equation that created this shape that I typed into Desmos graphing calculator. So now here is the more formal way of showing you the rules for a parabola for finding the focus and the directrix. Now this can be a little bit confusing, and that's why in general I'm going to refer more to the graphing approach for this. However, we do want to pay specific attention to the fact that there are two different ways to write the equation. There are the parabolas that open up or down. So like the one I was showing in the previous slides would have matched this formula because it opens either up or down. And then there are the parabolas that open to the left or to the right. And that flips a lot of the numbers in it. We still have 4p in the same spot, but a lot of the other x, h, y, and k values get flipped around. So what's being squared gets flipped around as well. Within the shapes, to determine whether it's the up or down case or the left and the right case, that's going to come down to whether the 4p value is either positive or negative. So you can use that to indicate which direction the parabola should open. The vertex is the same for both shapes, But as we move down to the other pieces, the focus and the directrix, the formulas for these look complex, but the easiest way to identify them is always look back at what P is touching in the equation. If P is touching Y, then you're going to add P to the Y coordinate of your vertex. So I added P to the Y coordinate because that's what P was touching, that's what created this coordinate. And then the same thing would happen on the other formula. If P is touching X in the formula, then you're going to add P to the X coordinate of your vertex. So it becomes H plus P instead. So that's why I wrote a little plus P next to the focus here. That's to remind you to add that number and then add it to whatever it's touching, X or Y. The directrix is the same idea, except this time we're going to subtract P. So if P is touching Y, you're going to take the Y coordinate of the vertex and subtract P from it. If P is touching X, you will take the X coordinate of your vertex and you'll subtract P from it. You'll also notice that the formula changes, whether it says X equals or Y equals. And again, that can be determined by saying which variable is P touching. If it's touching Y, it'll be a Y equals equation. If it's touching X, it'll be an X equals equation. So in general, always try to default back to that. Most of the rules for this shape will be based on what P is touching in the equation. And then the focal width is the same again for whether it's opening up and down or left and right. So before we get into the actual examples, I've given you a list of hints and shortcuts that you can use here. In the questions, you will either be given something like the vertex and the focus and asked to write the equation for it, or you might be given the directrix and asked to figure out the equation, or you might be given the focus and the directrix, etc. So each of these cases I have given you here is going to apply to the upcoming examples. You'll take the information you're given. You should be able to find all of the missing pieces that you need for the shape of the parabola. Again, I think it's very helpful to do this graphing them, just drawing a rough sketch and then measuring some of the distances. And then you'll figure out which equation to write based on the information you have and plug in the appropriate numbers. So the first hint was if you're given the vertex and the focus, look at what's changing in those coordinates, because both the vertex and the focus are ordered pairs. So if the y's are changing, if the y coordinate has changed, then that means you know that it's this case. It's the formulas on the left-hand side. If it's the x coordinates that are changing, then you know it's this case. So we use the formula with y squared in it. If you're given the equation of the directrix, well, that's great, because then the equation will either say y equals or x equals, so you'll know which column of formulas to use for writing the equation. If you're given the focus and the directrix, then don't forget that the vertex is halfway between them. So that's where drawing a sketch can be helpful. You can just measure the distance between those two objects and then find the point halfway between them. And then the last piece, and probably the hardest, if they just tell you what direction the parabola opens in, up, down, left, or right, and the focal width, don't forget the focal width is the absolute value of 4p. So you're not going to see on that whether it's a positive or a negative. So you'll be able to figure out the number, the absolute value of p, and then to figure out whether it's positive or negative, you'll have to look at the opening up, down, left, or right case, and those rules are listed up here in the second row. So for this first example, they've given me the location of the vertex. So I would start off by making a rough sketch going right 3, up 4, and then I would just draw a dot for that point. They've also given me that the focus is 5, 4, so I would go over 5, up 4, and draw that dot. And then you would refer back to the earlier slide. So remember that the vertex is the point on the parabola and the focus is what it's pointing towards. And I'll be able to use the distance between those 2 points to figure out how far away to draw the directrix as well. So since I can see the distance between these points was 2, I would go 2 more away from the vertex, and then this would be where the directrix line passes through. And then remember the parabola is going to go towards the focus. So I would expect my shape to look something like this. That can be helpful to figure out the rest of the information in the equation, because now I can compare it to the rules in the table. But we've already identified that the distance between those points was 2, so now I know p is equal to 2. And since they actually gave me the vertex, that means that I know h is 3 and k is 4, because the vertex is always your h and your k value, no matter how the parabola opens. So for writing the equation itself, I now know that this one is opening to the left or to the right, so I'm using the column on the right-hand side. We found that p is 2, so I'll have 4 times 2 is 8, and we know the h and the k values. So I'm just going to be plugging those numbers in. And again, this all came from the first bullet I had here. We were given the vertex and the focus, so I could look at the x coordinates, whether it was the x coordinates or the y coordinates changing, to also help figure out which direction it was going in. But I also just looked at drawing the sketch. I found that made it easier to identify, oh, well, the parabola has to go towards the focus, so it has to go to the right. So my answer for number 1, I have y minus k squared equals 4 times p, x minus h. For the next example, we have a vertex at 0, 0, so I would draw the dot there. And they've given me the directrix is the equation y equals negative 3. So I know that I go down 3, and then this is the line that my parabola is going to avoid. Now right away I can look at the distance between these two objects to find that p is equal to 3 in this case, which means I can go that same distance in the opposite direction, and that will give me the point for the focus. So now I already have a rough sketch of my parabola, which can help me with figuring out the equation. They gave me the vertex again in this example, so I can also label that h is 0 and k is 0. This case sometimes confuses students, so I do want to make sure I show you what happens when I plug these numbers into the formula now. So looking back at the table of formulas, I can use the second bullet, which said by the formula they gave me for the directrix. Since it was a y equals equation, I know to use the formulas on the left, but also by drawing my sketch, I was able to identify that it has to be the up or down case as well. So now we're going to be plugging in x minus h squared, 4 times p, y minus k. So what students sometimes miss in the case where h and k equal 0 is that we don't actually need to write plus or minus 0 when we're writing an equation. So in those cases, make sure you simplify it and just write it as x squared, and then the same thing over here. We don't need to write the 12 times negative 0 part. We don't need to write minus 0. We're just distributing 12 times y. Okay, here's example 3. This time we were given a point at negative 4, 3. And this time it's the focus, not the vertex. And we were given the directrix of y equals negative 1. So that means it has to be a horizontal line for this one. Now this time we weren't given the vertex, so we're going to need to figure that out on our own. So the hint I gave you on the other slide, it says to remember that it's halfway between these two objects. So if one of them has a y value of 3, and the other one has a y value of negative 1, you can cut that distance in half and see that it must land right here. So now I can quickly measure p by either going up or down from the vertex. In either case, I can see that p is 2. And if I identify the x and the y coordinate for the vertex here, h was negative 4, and k is the y coordinate of the vertex, which went up 1 tick mark. So knowing that the parabola will go towards the focus and away from the directrix, now I can see the basic shape of my parabola, and then we can write out the formula now. Be careful whenever you have negative numbers for h and k, because the formula is x minus h, so the double negative cancels and makes it a positive. And then if you have a positive number, you end up seeing y minus a number or x minus a number, depending on the formula you're using. So now one last example. We have the vertex is right 3 and down 1. They told us that the shape opens down, and they've given me that the focal width is 12. What you need to be careful with on the ones where they give you the focal width is you want to look back at the rules for whether p will end up being a positive or a negative number. Since it's opening down, I know that p has to be negative in this case. Less than 0 is negative. So when I'm solving that 4p equals 12, you divide both sides by 4, and we get 3 in this case. But we know that it has to be the negative 3 situation. So I'm actually going to change this to a negative 3 because I know that it's opening down and not up. And then the coordinate for h and k was given. So we have the vertex. That means h is 3 and k is negative 1. The fact that p was 3 means I could measure out the distance to the focus and the directrix as we did with the other examples. But for writing the equation, we have everything we need right here. So our final answer, the trickiest piece, was remembering that the p-value sign will be dictated by whether they say it opens up or down, or left and right if it was one of the side-to-side parabolas. So that's our final answer there. We have a negative on the p. And that's it for the lesson. So don't forget, drawing graphs, just a quick sketch can really help you a lot with figuring out the correct equation. Thanks, guys.